Good evening, one and all present here. We are Team Neuratech and we have worked on problem statement number one, that is the Global Catalog Registry, which simplifies integration between buyer and seller apps by providing centralized catalog storage. So, coming towards the workflow of our team leader Sumee Gupta has worked on MVC and API development. Atharva has worked on backend and API integration. Talha has managed database and its integration. Shashank has managed market research related work and operation plans. And I, Saherish, have worked on front-end and authentication of GCR. So I request Atharva to please carry forward and show the working prototype.
So, hello everyone. Now we will look onto the focus of our solution, which is majorly the centralized database. We have reduced the complexity from n into m to m plus n, which reduces the repetitive connections going from the seller and the buyer in the database, which benefits the user, seller, so that their workload is reduced, which also benefits the buyer applications so that they can fetch the efficient data in less mean amount of time. We have also leveraged our API architecture with various implementations in our API such as pagination. We have also implemented Redis caching. Our system is completely integrated with the Kafka to scale up very effectively. So now let's dive into our solution, prototype solution. So let's first log in. So this is the profile of the user, the seller, which is basically he can see all his data. The major feature of our application is to upload the products. The buyer, the seller can choose the various templates. He can of the various categories. If the field is not present in the template, he can customize the template and he can save it to the database, which will be later helpful for his uploading the products. The seller can also upload multiple products via CSV and Excel sheets. The major feature working behind this is the batch writing approach of the MongoDB, which helps in effectively using the OPS of our backend. The seller can also view the various insights of his data, such as brand, categories, availability of ranges, and various scatter plots about various distributions. So let's now look how our backend is integrated with the front end of the various websites like Flipkart, Amazon, and various other things. The major thing here, the buyer apps has just need to make the one API call, the one HTTP request, and they will get all the all this buyers sellers data to show to the buyers. The buyers can filter out it, search here, and the user experience gets so robust. Now, the major thing here is that we have optimized our database in such a way that the searching complexity has just reduced to O of 1, and all the product listing over here, along with the pagination, the time complexity required is O of n. Now I handle this to Sumit to show the code base of our solution. Got it.
Now let's move to our code base. Our code base includes the MD documentation, which includes our hosted website link as well as YouTube link. It includes a client, how to run the client server, and the important features which were mentioned in the problem statement. Then there is a API documentation, which includes all the API and how to use the API. For example, when we can see here, there is a seller API of register, which includes endpoint API type like post and the sample data to test the postman API. Then there is a server folder, which includes MVC architecture for a API. For example, there's a controller, which includes buyer and seller page, which includes all the API logic inside a function. Then which is directly passed into the roots. Inside the roots, there is a endpoints and the API logic function, which are connected. Then there is a model which includes buyer, catalog, seller, template, schema of MongoDB. In catalog schema, there is a dynamic fields schema which is available in the MongoDB. Then there is a root file index.js which connects the MongoDB database, the port, and the roots. Then there is a simple client application of React which shows how our API is working, and this API can be connected throughout the application as well as website as well as existing websites on internet like Amazon, Flipkart as well as Zepto and others. Now I will pass to Tala to explain a centralized database, MongoDB.
Mic बंद करो इसमें. So in the central database of GCR, we have utilized MongoDB due to its scalable features such as sharding, replication, and support for transaction. The database consists of three collections: seller, products, and templates. Seller collection contains information about different seller. Each is identified by a unique seller ID. It includes all the detail provided during the seller registration process. Also, it includes all the product that have been uploaded by the seller. Now coming towards the product collection, this collection holds the product catalog uploaded by various sellers. Each product is identified by a unique product UID. And it includes fields such as name, category, brand, and other attributes. Additionally, dynamic fields like price and availability are also maintained here to reflect real-time updates. Seller can also add their own dynamic field to customize product details further, enabling flexibility to meet specific requirements. Now coming towards the templates collection. For every product category, this collection contains predefined templates with fields relevant to specific category. One of the key features of our system is seller can create their own custom template based on the category. These custom templates are also stored in the templates collection, ensuring flexibility while maintaining compatibility with our existing schema. So in summary, the database of GCR is designed efficiently to manage and organize data for seller, product, and templates, leveraging MongoDB's powerful and scalable functionalities. So I will pass to Sumit to show the API architecture.
So this is a this is a centralized database architecture which includes all the fields available in this architecture includes in the MongoDB and the connection with each field to another. For example, catalog, seller, buyer, address, order, as well as templates. Now there is an API architecture of our API which includes how our API workflow happens. So for example, in add catalog API, there is two way to add products. For a single product, there is a validated product inputs and the products are inserted inside a centralized database. For multiple products, a CSV or Excel file is taken as the input and all the fields are validated and it is divided into batches to process and insert into the database. Then there is update product API, remove product API, retrieve template, and many others. So now I will pass Saherish to continue with use case and business model.
So this is our use case diagram, which consists of three actors: buyer, seller, and system. As we can see, there are various functionalities for seller and buyer, which is given by the system. And this is our business model. The GCR platform simplifies catalog management through seamless integration and centralized storage. It partners with ONDC and cloud platform to enhance scalability and user experience. Key activity include maintaining the platform, supporting onboarding, and ensuring data consistency and security. The GCR platform incur cost for cloud hosting, maintenance, customer support, continuous update, and promoting adoption among buyer and seller app. I request Shashank to continue.
So to understand the current market of ONDC better, we have conducted an in-depth market research of ONDC. So here's the alignment of a GCR with ONDC. Standardization, integration, efficiency, empowerment, scalability, unique IDs, decentralization, dynamic updates are required for the alignment. And the basic agendas of our GCR is to simplify integration for the buyers and sellers app, standardizing catalogs for unified structures and consistency, centralized storage to avoid duplications, seeded templates for ready-made templates for the seller, dynamic data for real-time updates and changes, efficient hosting for easy hosting and optimization, unique ID for consistency of product, empowering user for support and better experience. So according to the market research, the ONDC estimates to be a $400 million company by the year 2030. E-retail penetration by countries are as follows: India at 4.3%, China at 25%, South Korea at 26%, UK at 23%, other countries at 21.7%. The sources are been attached with the link. This is the basic markets research analysis for the ONDC. This is the challenges and consideration faced by the ONDC. So the workload balance for the seller in two different scenarios, one in which he has to list the product on different platforms like Amazon, Flipkart and Meesho individually, whereas in the other case when he has to list the product only on ONDC and the others will retrieve the data from there. So the comparative comparison results catalog preparation requires much more time for individual listing. Inventory updates requires multiple platforms. Support tools needed are separate for different platforms. Time spent is much higher than ONDC. Cost for the staff is much higher. So this is the estimated financial projection of expenses and revenue of the GCR. This is the SWOT analysis of GCR. And this is the easy integration of our GCR API with different apps like Amazon, Flipkart, and Zepto. Thank you for your time.